taking notes?
Happy Friday. This is going to be really quick.
Is this notes?
Yeah, we're taking notes. We're taking notes on antiderivatives. Yesterday, we discovered that antiderivatives are the same as the integral. We can use the integral to find area under the curve, but the integral is the same as the antiderivative. So,
could this go under the fundamental theory?
It can go under the fundamental theory. Integral and antiderivative are synonyms. But we're going to spend the next bit of time finding just antiderivatives, not necessarily areas under curves on specific regions.
Antiderivatives. For the entire line.
So we're not going to go from point A to point B. We're just going to say, in general, what is the antiderivative? So instead of getting an exact number answer, our goal is to get a function answer. And we're going to use some letters here. Let's see. This is the power rule. Forgot to write that. The power rule. Let's do A and B. I do this different every year, but A, X to the B. And just to be clear, we're taking the antiderivative with respect to X. Are you guys ready to go straight to this abstract concept, or do you want to do a couple examples first? Because you've done examples already. Yes, we did examples yesterday.
Let's just go straight for it.
You want to go for it? All right. A and B are constants. On your homework tonight, there will actually be numbers there. Okay. So this is asking, what is the general rule? What do you do with A and B to get the antiderivative? Thoughts?
You would add one to B. No.
You subtract.
Yes.
Yeah, you would add one to B, then times that.
So it's the opposite of derivative. So instead of subtracting one from B, we're going to add one to B. That's part of it.
Yeah.
The tough part is what happens to our coefficient?
It's divided by B.
Divided by
close.
B plus 1.
Divided by B plus 1. And that is all there is to it. That was the only goal for the day, is to get at the power rule.
What's a d of x?
When you integrate, it goes away. It's essentially telling you that we're taking the antiderivative with respect to x.
Okay.
It's an identifier.
System.
Another way of thinking about it is it's the rectangle that infinitely shrinks down to nothing.
No, same old.
Anyway, let's do like a basic example, and then we'll do a couple of annoying examples. So what is the antiderivative of, I don't know, 3x to the 5th? Dx. I frequently forget that dx, so feel free to yell at me if I ever forget it. Or maybe not yell. We don't want to be like the Houlihan's class, causing distractions.
How rude.
You really want to give it a try?
Sure.
Make the other two do the hard ones. What do we get there?
You got three over 1/2. You have 0.5.
Yep, which I liked what you said before you said that, which was a 3/6.
Yeah, 0.5 times 0.5x time to the power of 6.
It's just 1/2 then.
And you can do that in your head if you can. That's fine. Just out of curiosity, did you think about that term first, or did you think about the exponent first?
Thought of the exponent first.
Me too. I always think about the exponent first. I think, okay, it's going to be that new exponent, and then I'm going to divide by the new exponent.
Well, how would you even do the other one without thinking about that first?
Well, I think it's going to be...
Just think about B plus 1.
You're following that
as soon as you think about B
there's 2B plus 1.
As soon as you think about B plus 1, you've already solved the first half anyways.
True. I mean, you could think about it as first I'm going to divide by one more than that exponent. But I mean, it's all the same.
Still same answer.
Same answer.
We got the answer for it, even that.
Same answer. Alright, let's do a harder one. How could we make this harder? What made power rule derivatives harder? Did I give you any hard ones on the warm-up?
No.
I'll give you all easy ones. Darn it, I meant to do some hard ones.
Well, having a number be a fraction.
Yeah, so fractions,
Do derivatives too.
Ooh, negatives,
negatives, roots,
which are fractions.
which are fractions, yeah.
X's and exponentials.
Let's do the cubic root of x.
Yeah, but that's not a power rule anymore. That's chain rule.
And yeah, we're gonna get into that. Not today. So what is the integral or antiderivative of the cubic root of x? Perhaps, before you attempt this, it would help you to rewrite the problem. X to the 1/3 dx. Then it's just a simple power rule.
You broke my pencil.
You're amazing.
So remembering that roots correspond to fractional exponents.
So 1.33, so 1 1/3.
So adding 1 is 1 1/3 or 4/3, depending on how you want to write it. I always like improper fractions myself. And what is my new coefficient?
It would be 1 divided by.
And then that would be
Divide by the new coefficient.
Was that 4/3 for the exponent?
Yep. 1/3 plus 1.
Oh yeah.
If you want a little thought bubble there, feel free to write that in there. 1/3 plus 1, which equals 1/3 plus 3/3 equals 4/3.
3 looks like a 2.
Which one?
First one.
This one?
Be
No, the thought bubble.
3/4.
Oh, that one. And I'm hoping that during the process of doing these antiderivatives, you will start to not even do that step, what's currently my final answer, and skip straight to the actual final answer, which is what? What is 1 over 4/3?
3/4.
3/4.
If you need some more of that, I can give it to you.
Bam.
Oh, yeah.
One more, maybe with some negative exponents. Or, better yet,
Yeah.
well, that's not what I meant. The antiderivative of 30 over x to the 4th dx.
Oh, it's actually the 4th now.
I could also warn you at this point, sometimes in different looking problems, they might even throw the dx into the numerator. 30 dx over x to the 4th, but I'm not going to do that right now because I don't like the way that looks. Personal preference. Last example, and then I think we'll be done.
Oh, we don't have a game.
No, I didn't have anything fun planned.
What's PR?
Power roll, that's what we're learning.
Okay, so then I guess you make it -4.
Yep, you want to think about it as x to the negative 4.
30x to the -4. And then you take that and you make it 30x to the -3.
Yep, so remember,
But you
this,
get rid of that
this is
30.
not necessarily
So then you'd make it -10.
intuition. When
It's
we
negative-
add 1, it's
So
negative
it's
3,
-10.
and we divide by negative 3.
So then
Oh, I don't need the integral for this, do it. -10, x to the -3, or -10 10 over x to the third.
Okay, well, that's fine.
I think I'm done with the video.